Hello.
Hey, Ania, how are you?
I can't hear you.
Oh,
Oh, there we go. I can hear you now.
okay. How are you doing?
I'm good. How are you?
Fine, thank you. We'll be starting in a few minutes.
I can't hear you again.
What's happening? Okay. I said we'll be starting in a few minutes. Can
Okay.
you hear? Okay. Can you hear me now, right?
Yeah, I can hear you.
Okay, good. Let's begin. Um, Now, today, actually, this is a topic that I was supposed to introduce on Wednesday, but we didn't have a class on Wednesday. So we begin it today. It's called a test of hypothesis, regression, and correlation. Um, a statistical hypothesis, when we say hypothesis, basically, it is a claim about a population parameter. So that claim may be false or true, but it depends on when we test the claim, then we can decide whether it is a true or false claim. Now, when we're talking about this parameter, population parameter, we are, what we mean by that is parameter is a numerical description of population characteristics. Things like the mean. Yeah. Of course, you know how the symbol we use to represent mean. Here, mean. I call it population parameters. Parameters. Okay, things like the mean, mu. Okay. Standard deviation. Okay, which we use delta symbol to represent, or even proportion. P basically is percentage. So any claim we make about any of these population parameters, that's what we call hypothesis testing. So now in hypothesis testing, what we do is to define the population and specify the parameter that we are trying to make claim about. Then we state the hypothesis, and then we give the significance level, select the sample from the population, then collect data, perform the analysis, and then write a conclusion. Now, today, what we'll be doing today is basically to show you how to state hypothesis. On Monday, we will begin with stating hypothesis and analyzing hypothesis. So for today's one, our focus is how to state hypothesis. But before you can understand or be able to state hypothesis correctly, there are some basic concepts that you need to understand, and those concepts include things like the kind of questions that we address when testing hypothesis. Well, there are many types of questions we have to look at, or that we use hypothesis testing to answer. Some questions are such as, for those in the medical field might say, does a medication lowers blood pressure? Or those in the public safety can say, okay, does seatbelts reduce the severity of injuries caused by accidents? There have been many claims that it does. How are those claims proved to be true? Does the public or customer prefer a certain color in a line of fashion? This is for maybe a big store like Walmart or target can be asking this question, or maybe a tailoring company, and so on and so forth. There are so many questions you can answer using the hypothesis testing method. Like again, I say today we'll be focusing on how to state hypothesis clearly. And to do that, you need to understand this concept. Another concept we need to understand is the type of hypothesis we have. We have the null hypothesis and the alternative hypothesis. The null hypothesis merely make a statement about the value of the population parameter. It usually say that it is equal to something. A simplest way of explaining this that the null hypothesis is usually stated using these signs here. Some kind of the signs we use when stating hypothesis can be so any type of equality. Things like the equal sign, then less than or equal to symbol, and then greater than or equal to symbol. So these are the type of symbols we use when stating null hypothesis. Symbols for null hypothesis. And we use HO to represent null hypothesis. Okay. Now, the alternative hypothesis just says the opposite of null hypothesis. And for that, we use this symbol, not equal to, greater than, or less than. So this means that you cannot use not equal to symbol in the null hypothesis. You cannot use greater than symbol in null hypothesis. Instead, you're going to use greater than or equal to. Also, you cannot use less than in the null hypothesis. Instead, you use less than or equal to, and vice versa. Now, any question on that so far? Any question, class? Hello?
I'm here.
Any question for me?
No questions.
Now, let's look at the type of errors. Because like I said, you need to understand this before you can be able to state a clear hypothesis. We have the type 1 error and type 2 error. Type 1 error occurs when we reject null hypothesis that is true. That means we say we have committed a type 1 error. And type 2 error is when we do not reject null hypothesis that is false. We say that we have committed type 2 error. I will explain how this works. Usually we use a decision matrix. See HO true, HO false. Reject HO. Do not reject HO. So this place is very important because I'm going to put discussion 2 as part of your assignment next week. So I need you to understand this section about type 1 and type 2 error. So it will be the second discussion question you will have, and that will be the last discussion question for this class. So that means you have only 2 discussion questions, 1 and 2. So now this here says if HO is true and you rejected it, that's reject HO, that means you have committed type 1 error. If HO is false and you reject it, that means you have made a correct decision. Now, if HO is true and you did not reject it, you made a correct decision. If HO is false and you did not reject it, you have committed a type 2 error. So let us see how this works. I'll use a real life scenario to explain this. Let's suppose we use the an example here. Let's say use this example. Well, this is what I'm going to give you in your discussion question. So let me use an example here. A different example. Let's say we use a legal system. Example. Let's say we use our legal system. Or even, okay, we have medications, vaccine for COVID, for example. Okay, let's use that, the COVID vaccine. In this case, we have 4 scenarios. Okay, the first one is this: the vaccine, okay, protects from COVID-19. Okay. 2, the vaccine do not protect, or I would say prevent COVID-19. Okay, let's say prevent COVID-19 infection. The vaccine do not prevent COVID-19 infection. Yeah. And the third scenario is the nurse gave vaccine to patient. It's injected vaccine to patient. Okay, 3, 4. The nurse did not give vaccine to the patient. Now, these are the 4 scenarios. So I want to use these 4 scenarios to explain the meaning of type 1 and type 2 error. So you can see how it works. So in this case, null hypothesis might be null hypothesis, which is our HO. The vaccine do not prevent COVID-19 infection. Okay, these are based on sample estimate. We use a H1, that is the alternative. H1, the vaccine prevents COVID-19 infection. Say, these are the H1. Now, so we have it in this form, and then we have HO2. Let me see, let me put this way. HO2 means do not prevent. Okay. You know what? Let's make HO prevent, and the vaccine do not prevent. Do not prevent COVID-19 infection. Okay. Let's HO means prevent, vaccine prevent. Okay. COVID-19 infection. HO false, do not prevent. Prevent COVID-19 infection. And we have now reject HO means that they inject vaccine to patients. Do not reject HO means did not no injection given. Okay, good. Now now we can be able to figure out the type 1 and type 2 error. Or now you know that usually the null hypothesis said is like I would say general statement. So I have to correct this again. Vaccine do not prevent, the vaccine prevents. Okay. Right, now, let us figure out which is type 1 error and type 2 error. If the vaccine, excuse me, let me write this. Okay, good. You see it. Now, if the vaccine prevents COVID-19 and you give injection for it to prevent it, that means you have made a correct decision here. Correct decision. Sorry, my mistake. This is because of this change I made here. You have to. I'll have to change this one. Do not prevent. Then here, HO false will be prevent. Vaccine prevent COVID-19. Prevent. Okay. Now, if the vaccine do not prevent COVID-19, but yet the nurse gave you the injection, then the nurse have committed type 1 error. See? Excuse me. Now, if the vaccine prevent injection, prevent COVID-19, and the nurse gave you the vaccine, the nurse have made a correct decision. Okay. Now, if the vaccine do not prevent COVID-19, and the nurse did not give you any injection, that means no injection given, they didn't give you the vaccine because it doesn't prevent COVID. That means he or she has made a correct decision. Now, if the vaccine prevents COVID-19, but the nurse rejected HO by not giving you the vaccine, he or she have committed type 2 error. So that's basically what it is. Type 1 and type 2 error. Any question for me on this? Any question?
No questions.
Now we can now look at how to state hypothesis. Now, to understand this better, we need more information. Okay, let's see. Yeah, this is basically where we are today, how to state hypothesis, since we now know the type 1 and type 2 error, and then we understood the type of hypothesis we have, and also the kind of test, the type of things that we use hypothesis test, the type of problem we use hypothesis testing to solve. So let us see how to test the hypothesis themselves. We have, since you have no question, I don't have to show you another example of this decision matrix. So there's no point. Let's go to stating hypothesis. It says here, state null and alternative hypothesis for this conjecture. Okay. Now look at the first one. First one says our solution. It says that a researcher thinks that if expectant mothers use vitamin pills, the birth weight of their babies will increase. Let me make this bigger. Okay. It's a researcher thinks that if expectant mothers use vitamin pills, the birth weight of their babies will increase. The average birth weight of the population is 8.6 pounds. So let us take the hypothesis here. So we have now the thing you look at the keywords, the average birth weight. So this is have to do with the mean. He said that it will increase. We increase the other keyword. So we increase and the average birth weight are the keywords. So the hypothesis will be as follows: HO, because this is average, you're gonna be mean, and the H1, we need H1 as well. Usually I say put H1, and then the opposite will be H2, sorry, H0. Now, he said the birth weight will increase. We increase mean greater than. And you know that you can only use greater than symbol in the alternative. So that means you're gonna do that one first. Have H, I mean, it's mean, the birth weight mean, we increase means greater than. Okay, this would be somewhere here, right here, 8.6 pounds, which is his claim or her claim. Then HO will be the opposite of that. HO. Sorry, I have HO already. So now HO would have been less than 8.6 pounds, but you cannot use less than symbol here. So you're gonna use the one that we call less than or equal to. So mean is less than or equal to. Okay, less than or equal to 8.6 pounds. See, and that is how to state hypothesis. So you have 3 hypotheses for this one. Questions?
No questions.
Okay, good. The other example would be number 2. Let me make it bigger. Say solution. Says here that an engineer claimed that the mean number of defects can be decreased in the manufacturing process for compact discs by using robots instead of human beings for certain tasks. The mean number of defects per 1,000 is 18. See? So prior to this, test, the mean number is 18. So, but he's claiming that then that the mean number of defects can be decreased in a manufacturing process for compact discs by using robots. So here are the keyword: mean number of defects. I mean, you show that they are average. Then another keyword here is we can be decreased. That's decreased, which show that you're going to use the less than symbol. So you have your HO and your H1. Yeah. Just give me 1 minute. Let me send a message in remind.
Okay.
Just 1 minute. Let me send a message because some of you are absent today. Okay, let me see. Okay. See. Okay, let's see here. Remind. Okay, yeah. Let me see. Remind. Okay. Okay, this is your class right here. Okay, let me send this so that they can. Okay, look out from here. So let's go back. Now, continue with this, we have HO. So like I was saying before I went to send that message, we have that the mean number of defective is per 1,000, this is 18, but he's claimed that this defect can be decreased, which is the keyword, decreased, by using robot. So let's say decrease will mean will be mean will be less than, okay, 18, which is the claim. Which is the claim he's making. Claim. Now, the opposite, which is the HO, will now be mean greater than 18 this. But you cannot use greater than symbol in the null hypothesis. So the opposite will be greater than, but you can't use it in the null hypothesis. So you're gonna use greater than or equal to. Why? Because the null hypothesis, the symbol you use here should have some kind of equality, like equal sign, less than or equal to, greater than or equal to. But in the alternative, you can use less than, greater than, or not equal to. So the opposite now becomes mean greater than or equal to 18. Questions? No? No questions. Very good. So, and on it goes. The next one we need to state, the next hypothesis we need to state is this one. Now, you notice that the one we have stated so far are basically for the mean and for the mean. If this one will be for the mean, because the questions always say the average. Sometimes you can also test hypotheses that are not for the mean. For example, for standard deviation, for variance, and for proportion, and so on and so forth. But we'll come to that eventually. This hypothesis here says a psychologist see that playing soft music during a test will change the result of the test. The psychologist is not sure whether the grades will be higher. In the past, the mean scores was some 3. Now, in this case, he doesn't know whether it will be less than or greater than, but he said that it will change. So that means the score can increase or it can decrease, but it has to change. So in this case, you have your HO and H1. Well, prior to this experiment, the mean score in that test is just the average score is 3. But the keyword here it says is the change. Change can be for less or greater than. Another keyword here is the mean. That means the average score. So that having that in mind, you say that it will change. So it can be greater than or equal to, or less than or equal to. So we don't know. So that means here we're going to use the symbol mean. Mean not equal to, because we don't know whether it will increase or decrease. So not equal to, whatever change it will be will not be the same as 73. But we don't know whether it is less than that or not, or greater than that. So we have 73, which is the claim that it will change. Okay. Now here, the opposite of this will be equal. So we have mean equal to 73. So that's the hypothesis. Now, in all example we did so far, the claim we are in the alternative hypothesis. Claim here, and claim. Now, you can also have claim in the null hypothesis. It can be anywhere. So long as it is what the researcher is claiming, that is whether the claim is in the null hypothesis. I mean, if it is in the null hypothesis, then you put it in the null hypothesis. If it is in the alternative hypothesis, then you put it in the alternative hypothesis. It has to be where the claim is made. Now, so let's look at another example here. It says at least 45% of senior citizens were hearing aid. So we have at least 45% of senior citizens were hearing aid. Now, this time around, they didn't use the mean. They used percent, which is the proportion. So this is how it said HO and H1. Now, it says at least 45%. At least means greater than or equal to. So greater than or equal to is you use it in the null hypothesis. You cannot use it in alternative. So that means proportion P is greater than or equal to 45%. See, that's the claim right here. This time around, the claim is in the null hypothesis. Now the H1 is P. Now the opposite of greater than or equal to is less than or equal to. But you cannot use less than or equal to here in the null. Sorry, in the alternative hypothesis. You can only use less than. So we're gonna use less than right here. Less than 45%. For this one, do you have any question on this one?
No questions.
Good, good. Right, then look at another one. I says, number 5 says, it says more than 70% of college employees contribute to the United Way Fund. More than is means greater than. So with greater than symbol, you know that it will be in the alternative because you cannot use greater than symbol in the null hypothesis. Okay. So more than will be in the alternative. So, and because it is a percentage, I mean, it is for proportion. P more than is greater than 70%. Now, the alternative to the opposite of this is less than 70%, but you cannot use less than symbol in the null hypothesis. So you're going to use the less than or equal to. Okay, less than or equal to 70%. So in this case, they say more than 70% of college employees contribute to, which is more than right here. So that's the claim is, and in this place. So, next one is number 6. Number 6 says the average income of accountants is $51,000, $51,497 per year. So you have HO and H1. So the average income. So the keyword here is. Is means equal sign. So that means it is in the, and you can only use equal sign in the null. So you have P equals 51,097, which is the claim here. And the alternative is P. The opposite of this is not equal to. 51,097. So I have given you many examples on how to state hypothesis. Let me, the last example on that, then we round up, will be this one here. It says, the average age of attorneys is greater than 25. This one is average. So I use P. Sorry, it gotta be mean, not P. Mean. Sorry about that. This is mean. Okay. Now, you see the average age of atom is greater than 25.4 years. So solution. So the keyword here is, you say greater than, I mean, you use greater than symbol, and then the average age. So you have equals HO and H1. In this case, you're gonna use greater than, so it says greater than, so that means greater than symbol can only be used in the alternative hypothesis. Okay, we have it as 25.4 years. And the alternative will be HO, the opposite of this, which will be less than, but since you cannot use the less than symbol here, you have mean is, you can only use less than or equal to there. Less than or equal to 25.4 years. Now it says greater than 25 years. That means this is the greater than here. That means the claim is located on this spot here. Okay. Now I've shown you these examples, how to state hypothesis, and I have explained the concepts, the decision matrix. Like I said, I'm gonna post one more discussion questions. One more discussion question that will be in next week, and it will be based on this decision matrix. Okay. Now, when we come back on Monday, we'll start with the type of other terms that we use when testing hypothesis, and then the steps. Then we do some examples. Okay. Oh, now I have also, your project is ready. I posted it today, so you can start working on those projects. You can begin it little by little, maybe 2 question by question, step by step. And next week I will explain more. One more, I will explain more about the project. Okay. Any question before we leave today?
No question.
No questions.
Let me just write your name, check your name, and then got an here, and I got Aaron. All right, I'll see you on Monday. You have a nice weekend.
Have a good one, you too.
You too.